Databases store data, but SQL is how we tell a database what to do with that data. SQL stands for Structured Query Language, and in one sentence, it is the standard language used to create, read, update, and manage data in relational databases. The key idea to understand is that SQL is declarative. In normal programming, you write step-by-step instructions, loop through this list, check each value, keep a counter, sort the results. With SQL, you do not explain the steps, you describe the result you want. You might say, give me the names of customers from Canada, ordered alphabetically. You never say how to search, how to sort, or which data structure to use. The database figures that out for you. That difference matters because databases solve hard problems that normal files and normal code are bad at. Real databases store huge amounts of data. They are used by many people at the same time. The data must stay correct even if the system crashes. Queries must be fast, and access must be controlled. A database is not just storage. It is a complex system that handles all of this continuously. You could try to do this yourself with files in a programming language, but it would mean writing your own searching logic, indexing, concurrency control, crash recovery, and security. Every application would need to re-implement the same fragile machinery. SQL exists so that application developers do not have to rebuild a database from scratch. Relational databases organize data into tables made of rows and columns. Tables are connected by relationships. SQL is especially good at working with these relationships. If customers place orders, SQL can connect the customers table to the orders table and answer questions that span both. This operation, called a join, is one of SQL's core strengths and is extremely difficult to do efficiently without a database engine underneath. SQL is also about correctness, not just querying. You can tell the database rules that must never be broken. For example, every order must belong to a real customer, or an account balance can never be negative. These rules are enforced by the database itself, not by scattered application code, which makes the data far safer. Another major reason databases need SQL is transactions. A transaction groups several changes into one all-or-nothing operation. If you transfer money between two accounts, either both updates happen or neither does. SQL gives a clean way to request this guarantee, and the database does the hard work of locking, logging, and recovery. Because SQL is declarative, databases can also optimize performance. The same SQL query can run faster tomorrow than today without changing your code, simply because the database adds an index or chooses a better execution plan. Not every database uses SQL, but relational databases revolve around it, and many newer systems copy its ideas. SQL exists because it solves the recurring problems of shared, persistent, structured data. Databases need SQL because they need a clear, safe, high-level way for humans and programs to ask for results without micromanaging the machinery underneath.